Hello, I am one. This is a lesson called Graphing Linear Inequalities in Two Variables. And it's an extension of our discussion about inequalities. So we've talked about inequalities and compound inequalities as we've graphed them just on a number line. Now, this idea can be extended to graphing on the coordinate plane as we now talk about graphing linear inequalities in two variables, x and y. So graphing linear inequalities, you remember graphing lines, and as a matter of fact, we're talking about this is based on the idea that linear equations in an x and y can be written in the form ax plus by is equal to c. And you can actually conform these things. As a matter of fact, I'll just show you how we can do this. If I just subtract ax from both sides, I end up with by is equal to c minus ax. And then if I divide everything by b, I can move things around and I can get y now equals negative a over b x plus c over b. And if you look carefully, that is slope-intercept form. So we'll be talking about that later too in today. A linear inequality, so we just talked about linear equality because we had an equal sign here. Now we're talking about linear inequality. So look at what we're doing as we talk about that. Standard form of a linear equation is that, but now with linear equalities, we're replacing the equal sign with in the first case here, ax plus by is less than c, so our inequality is less than. The next one is ax plus by is less than or equal to c, and ax plus by is greater than c, and finally ax plus by is greater than or equal to c. So an ordered pair xy is a solution of a linear inequality if the inequality is true when the values of x and y are substituted into the inequality. And we're going to go right into talking about that and showing what that really means. So take a look here in example 1. We're talking about checking solutions of inequality. So we're checking whether the ordered pair is a solution of 2x minus 3y is greater than negative 2. Now we're going to put in 0, 0, where x is 0 and y is 0, and when we do that we get 2 times 0 minus 3 times 0, and that's greater than or equal to negative 2. That's what we're asking. Is it greater than or equal to 2? Now, so that turns into 2 times 0 is 0, minus 0 becomes 0. Is that greater than or equal to negative 2? Now, since 0 is to the right of negative 2, the answer is yes, it is. So that is a solution. So that's a good way to do it. Now let's check for b here. B is going to say when x is 0, so we got 2 times 0 minus 3 times 1, is that greater than or equal to negative 2? Well, 2 times 0 is 0, minus 3, is that greater than negative 2? Or is negative 3 greater than negative 2? And negative 3 is to the left of negative 2, so no, this is not true. No. And so that is not a solution. So I'm going to write that. Not a solution. Okay, so there's that. Now let's check and see if here's one that has no zeros in it. The point is 2, negative 1. So x is 2 and y is negative 1. Let's see if that gives us truth in this inequality. So we go 2 times 2 minus 3 times negative 1. Is that greater than or equal to negative 2? So let's just check that. 2 times 2 is 4. Minus negative is going to be plus 3. is that greater than or equal to -2? Well, 4 plus 3 is 7. Is it greater than or equal to -2? Yes, it is. And so that is a solution. So 2, -1 is a solution, is what that says. So that's how we check solutions of an inequality, is you just plug in the x and y values of a point. All right, what if we're talking about now graphing a linear inequality? So remember when we were talking about um, linear equalities, we were talking about graphing, the equation of a line. So now we're talking about graphing a linear inequality. So here's the thing that I want you to understand. Whenever you're talking about the coordinate plane, you have to realize that any line that you draw, and I'm going to draw this one like this, any line that you draw really breaks the plane up into two parts, into two halves. And let me just kind of demonstrate that a little bit. If I want to show what those two halves look like, there's this side of the plane. So that this means that everything in the plane on that side of the line is part of the inequality. The other side then is going to be like this on this side. So what I'm trying to say is that you can take any line and you can split the coordinate plane into two parts. And that's the idea here, okay? So the graph of a linear inequality then in two variables is the graph of the solutions of the inequality. So remember, we were checking for what are solutions and what are not solutions. And so, for instance, the graph then of what we were measuring up above was 2x minus 3y is greater than or equal to -2. The line itself is actually shown here, and then it's actually shaded to the lower right. So every point in the shaded region and on the line is a solution of the inequality. And all the other points on this plane then um, is not a solution. And so you need to understand that. So in other words, all the points that are over here in this white area are not solutions to that graph. And we plugged them in earlier, and so you'd be testing those and saying, nope, those are not solutions. And so want to take this a little bit further into just talking about what it means to be graphing then a linear inequality. So step one, when you're graphing a linear inequality, you pretty much are focusing then on the equation of the line that we're talking about. So graphing, so the first thing is you graph the corresponding equation. You graph it as though it is an equation. And then you would use dashed lines of the inequalities when you're dealing with greater than only or less than only to show that the points on the line are not solutions. And so notice in my drawing here on the right, I created a line made of dashes, and that's what it would look like. Now, what I'm trying to say is that that's really the same as when we were graphing on the number line. Remember, we were using an open dot, like that guy right there. Okay, so this dashed line then is really saying exactly the same thing as that open dot. Um, the other case is that if we can equal points on the line, then we're talking about being on the line here, and we would make it a solid line, and we would use a filled in dot to represent that when we were doing it on the inequality. So wanted to make sure that you understood that, okay? So you use a solid line for inequalities when you're using greater than or equals to or less than or equals to. That's when we draw the solid line and show that the points are on the line that are solutions. Step 2, the line you drew separates the coordinate plane into two half planes. That's what I was trying to describe a little while ago. That we have two half planes. One is on one side of the line, and the other half is on the other side of the line. So test a point on one of the half planes to find whether it is a solution of the inequality, and that'll help you identify which is the side that is true and which is not. Step 3 says, if the test point is a solution, then shade the half of the plane that it is in. If it is not, then choose the other half and shade that. Now let's take what we've just talked about and do example 2, graphing a linear inequality. We're being asked here to sketch the graph of x is less than -2. So what we need to do is to start off by graphing x is less than -2. Now remember, that's going to take using a dashed line because we're only talking about less than and not less than or equal to. So if we call this -1 and -2, then I'm going to put a dashed line right at -2. And then if you feel the need to, we can figure out a test point. And I always like to say that 0, 0 is an outstanding test point. So we're going to use 0, 0, meaning x is 0 when y is 0 as a test point. That's this point right here at the origin. And we're going to check that. So the math is really easy because we just basically say, is x less than -2? Well, the answer is no, because 0, which is less than -2, is not a true statement. So that's not a true statement. And so therefore, our shading is going to be all on this side of the graph, the opposite side of where our test point was. And so there we're going to shade it. Now, I'm using a big fat pen and shading in and making big blotchy marks. For your sake, it would be sufficient to just simply use lines. And so I suggest that people just put in lines like that, and that's enough to show shading. Later, that's going to come in really handy because when you're graphing multiple shadings, it's easier to see the differences when all you use are lines. All right, so now we're going to be using example 3, graphing a linear inequality, to show you another form of that graph. So we're saying sketch the graph now of x is greater than or equal to -1. So we find -1 on the graph and on the x-axis, and we draw a line through it. Now remember, this is a solid line, not a dashed line. So we're drawing a solid line to show that it can be equal on that line. And the other thing that we do is identify 0, 0. There it is right there. And so we're going to test and see, is 0, 0 in part of the truth set for this equation. So we have 0, is it greater than or equal to -1? Now, since 0 is to the right of -1, then yes, this is true. So we can shade in the side to the right of this line. And so here we go. And once again, as I'm finishing shading this in, I want you to see that you can just use lines, to shade it in. So there's the shading, or you could have done it this way by just going, yep, there's my shading right there. All right. Example 4. Now we're changing something that was given to us in standard form and changing it to slope-intercept form. And you'll see that we can do this. This is just fine. So we're going to take x plus y is greater than 3. We're going to subtract x from both sides, and that gets x away from here. Now we have y is greater than negative x plus 3. We don't change the inequality just because of that. So, but now we're going to graph this, and so we're going to start by graphing this, and we know how to graph in slope-intercept form. We start by finding where the y-intercept is. Y-intercept is going to be 3 up, so 1, 2, 3. There we are. And we have a slope of -1. That means we're going to go down 1 and over 1 and down 1 and over 1. And we know that these are points that are on that line. So we can just go ahead and graph that line. And actually, I'm going to graph it as a dashed line because it's just greater than without the or equals to part. So there we go. We're graphing a dashed line that breaks up the coordinate plane into two parts, above it or below it. And now what we want to do is use, once again, the origin to see if we have truth where the origin is located. So we're going to say 0 is greater than -0 plus 3, or is 0 greater than 3? Let's see, is 0 greater than 3? No, 0 is not greater than 3. So that automatically tells us then that our shading is going to be on this side of the dashed line that we just drew. So there that is. And I'll just finish this real quickly. And there is the graph of this inequality of a line that has a slope that's different from vertical or horizontal. So here we are doing example 5, which is called modeling a real-life situation. Modeling with linear inequality in this case. You are on a treasure diving ship that is hunting for gold and silver coins. Objects collected by the divers are placed in a wire basket. One of the divers signals you to reel in the basket, and it feels as if it contains no more than 50 pounds of material. If each gold coin weighs 0.5 or half an ounce, and each silver coin weighs 0.25 or quarter of an ounce, what are the different quantities of coins that could be in the basket? So we're wanting to know how many gold coins and how many silver coins there are. Well, we're going to start off by talking about that 50 pounds part. It says it feels as if it contains no more than 50 pounds of material. So we're saying 50 pounds, and we're going to convert that to ounces so that we're dealing with everything being the same. I know that there are 16 ounces in 1 pound, and so when we multiply that, pounds cancel as units, and 50 times 16 is 800. So we end up with 800 ounces is what we're dealing with here. So according to this problem then, 800 is the most that we can possibly have. So that means that everything else by comparison is going to be less than or equal to 800. Okay, now if we say that there are X gold coins and Y silver coins, then we can say 0.5 ounces times X is the weight of all the gold coins. And we could say 0.25 Y is the weight of all the silver coins. So if we take those two expressions and add them together, 0.5x plus 0.25y, then the entirety of that will be less than or equal to 800 ounces. So here we are. So we can go ahead and graph this, and let's do it this way. I'm going to change these to fractions. And actually, we can get rid of our fractions if we just multiply everything by 4. So I'm going to multiply everything by 4. And watch what happens. We end up with 2x plus y is equal to, we're also multiplying this side by 4, is less than or equal to, 4 times 800 is going to be 3,200. So we're going to make this very top mark up here above the graph 3,200. And that means then that the y-axis is focusing on silver coins. So we're just going to say silver coins. And we're going to mark the x-axis as gold coins. So gold coins. So you'll see why I'm doing this, but we just marked 3,200 at the very top of that graph. We're going to mark on the other side 1,600 is going to be this mark right here. And that's the number of gold coins. So we're just going to call that 1,600. And that was because I had to divide by 2 with the x's. All right. So if you were to draw that line then, we're talking about everything from 3,200 silver coins. That would mean that there were no gold coins, or that there are 1,600 gold coins and no silver coins. So there's what our line looks like. And we have less than or equals to, so it is a solid line, and so we've drawn that correctly. So we're talking about less than, and so we want to know which side we are shading. And so the shading is going to look like this, and I'll go ahead and just draw it in. So it's everything greater than 0, right? So we cannot go below the x-axis, and we can't go to the left of the y-axis because we're not paying any silver coins or gold coins to the ocean. And so there we are. So there's the possibility of all the coins. So I could just kind of pick a spot here and say, how about this? Could I have as many as, let's see, 1, 2, 3, 3/8 of 1,600 would be about 600 ounces of gold coins? Yeah, I could. And if I had that, then that would match up with about 1,600 silver coins. So that's how that works, and that's how modeling works, and just gives us information showing all the possibilities for a real life situation like that. So homework is this. We're going to, there are 22 problems on a sheet of homework paper that I've given you in Google Classroom, so look for it there. Pull out a notebook or a piece of binder paper and take a photo of your work to submit the assignment there. And if you have questions and would like to know how to solve some of these problems, I'm happy to talk to you, so please let me know, and we can set up a time to meet in study hall.